We thought to do this presentation in a way actually corresponding to what you said. First, we're gonna briefly present the projects which we are doing through actually build stuff, through kind of what we managed to realize in last 5-6 years maybe. And then just to provide sort of a peek on the educational process, we would take one particular year, last year, not 1920, but 2018, 2019, and really go through 3 different tasks which we gave the students, so you really see how it's going on through one particular year. Yeah, so as I said, first couple of projects, and through them maybe to introduce our studio. Our studio was very much interested in applying new computational techniques to architecture and how they change architecture and how what kind of tools the computation brings and what kind of consequences it has. Obviously, we're also inquiring this obvious problem, what is the result, since architects generally build buildings and in school there isn't much space for that. Is the result a design, a model, etc.? As most of architecture studios, we try to cover different phases, but we were always interested in actually building something one-to-one, because that's where you actually encounter many problems, fabrication problems, but also spatial problems, general design problems. The first project I'm showing is the exhibition we made for Milan Design Week in 2018, I think. The overall topic was the topic of cave as a kind of archetype, architectural archetype of interior space. We had several students' projects, mostly team projects, presented there. What you see here is one big acoustic cave pavilion. I'm going to talk about it a little bit more. And then in the front, you see also kind of furniture interpretation of the topic of the cave, this not very defined topological play, which was resulted in this chair prototypes or sofa prototypes. Most of the projects we're doing here, especially the ones which are going to be built, this was a team effort, because architecture is a team profession, and it's really important. And sometimes it's a struggle to teach students to work in a team and to collaborate, also in the artistic part, but also in more kind of pragmatic part or technical part. The idea was to kind of combine very predetermined mathematical or generative approach with non-determinant material behavior. We're looking into the particular material, into foam and into the expansion of foam. And we created some sort of a method of how to simulate this expansion and how to control this expansion within rather rigid geometries of these polygons, truncated tetrahedrons. The process of how foam solidifies and expands has defined sort of smallest possible discrete elements, and has defined the shape of the overall structure in a way which could not be quite predicted before we started physical testing. So the result is this what we call cave pavilion. Again, what was interesting for us in the topic of cave is that it's a space of very unclear or undefined topology. You never know what's really inside, what's really outside. There is lots of this in between territories, and also the fact that it's sort of interior which grows into exterior. Jumping to the next. I don't know if you how we should do this. Feel free to interrupt me, or Imro can interrupt me if you want. Otherwise, I'm gonna just continue. Jumping to the next.
Shota?
Yes.
I will. I'm watching and I'm following, and also the participants or people who are watching us, they can either raise their hand and ask a question. That's one option. Another option would be they can actually post a question into the group chat. Another option is that there are people who are watching us on Facebook and they can ask a question on Facebook. I'm actually watching all these options, and whoever has a question, just don't hesitate to interrupt us. Otherwise, just continue without interruption.
Okay. I don't see any hands, so
No,
you tell me.
I will let you know. I will keep moderating.
Great.
Okay.
So I'm just continuing this one again. Pavilion project. We love pavilions because it's something which is already almost like a building. You can come in sort of, and when you build it, you encounter very real problems which you encounter when you build buildings, like structural issues, etc. But also it's something which is feasible to do with a budget. With a school budget, with the budget which we can have in our studio, and also with students' help, because obviously we are not hiring construction companies for this kind of stuff, and within the school timeline of 1 semester or 2 semesters occasionally. This one was a bit more moderated by myself. The previous one was more of a students' team effort. This was part of my PhD, but again, we did several workshops with students, and there were several collaborations. The general issue was again the same: how to create a shape which overall would be limited by constraints, whether these are site constraints or structural constraints or constraints dictated by the architect just because, but yet driven by some unpredictable material process. In this case, the bending behavior of wooden veneer, and the fact that the veneer behaves very differently because of its different structure. It's heterogeneous material, and because of the difference in the environment, depending on what the humidity, etc. Again, the process started with trying to understand the veneer behavior, and with creating a simulation, physical simulation. In this case, we used kangaroo and grasshopper, of how the veneer bends, what kind of forces are in play. And then that led us to the understanding of how we can pre-program this bending behavior. So by connecting several layers of veneer and pre-stressing them, not equally, but in very kind of intelligent way, you can make the veneer bend in a way you want it to bend. However, this is again a sort of overall constraint, the big picture. However, in the small picture, the particular shape is always dictated by tiny differences in the material, by the environment, humidity, wind, etc. So while overall the pavilion was this kind of simple half donut shape, because that was the site requirement, it was in the fountain during the winter when it was empty. In detail, you see this kind of richness of different curvatures, which is dictated by the richness of the material. Jumping to the next project, this one is probably the most predetermined or predictable. It was a collaboration with architecture company ITB, Shebolichy Architects, who were kind enough to decide to integrate some sort of an art installation or some sort of a pavilion within their apartment project. and they decided to make a students competition, open students competition for Czech and Slovak students. And we asked all our students to at least try and propose something for that competition. Eventually, not everybody has participated, but many did. And Ján, I believe you were in the jury, right, of the competition. And one particular design by one of our students, Jan Kovaříček, was selected. Actually, more than one design was selected for the second round. There were a process of testing and prototyping, etc., etc. However, eventually Jan's design was selected, and then since it was not temporary project, it was sort of long-term, and there were some issues with fabrication and building law. Jan collaborated with us as studio leaders, but also with me as part of COLARC, my professional practice, and we're lucky enough to bring this into realization. Hopefully, it still is there. The project was about creating an iconic mark or iconic spot in the apartment complex, sort of a very abstract logo, which also kind of provides a link to the to the idea of public space and playground, which is located somewhere there, and somehow cooperates with the existing architecture of the apartments. And finally, well, it was obviously great, and we love to do pavilions. Unfortunately, it's not always possible. We also do exhibitions. I'm gonna end this with this particular exhibition, which was done just as previous project. This was done for a kind of private client. We collaborated with Austrian entrepreneur who was interested in the topic of co-innovation. He has acquired a space in Vienna to be a sort of a hub for innovative and creative types. And we agreed that we would do, our students would do several proposals of how to transform this space, having in mind this topic of co-innovation. This is this was a little bit different from the previous projects I shown, because it was much less about prototyping and material studies, and much more about sort of abstract thinking of what is co-innovation and what's the relation of architecture to the topic, and how can architecture manipulate people into being more innovative and into more creative. Maybe manipulate is a negative word, but maybe impact people. However, you know, we always want to kind of touch what we do. So it's never just about some idea. We think that ideas are important, but you need to test them in order to them to be developed. And architecture is never just in your mind. And we thought we had this opportunity to have an exhibition in Jaroslav Ragnar's gallery, architecture gallery in Prague. And we thought, okay, unfortunately, we're not building it one-to-one, but still, how to test it? Let's make a really big models. And you know, when you do stuff, when you do really big scale things, big scale models, it's almost there. It's almost like one-to-one. And I think the projects which were developed during the semester, mostly in computer with some small scale tests, have actually moved on immensely during 3 weeks or 4 weeks of preparation of this exhibition, because of this materialization process. 3 projects shown there again were a team effort, and they were working with kind of dissecting the building, and each project takes place in a different space. Yeah, so some images of the projects. I'm not going to go too much into detail. I'm just going to jump now to the part when we talk about one particular year. Maybe Imro can say something about the tasks.
Yeah, there are some other projects from the year 1918, which were exhibited in, no, this is from 1919 to the 2019, exhibited in Ars Electronica in Linz in previous year. And we exhibited 3 projects, 3 post-Anthropocene projects and projects about new habitats, new ornaments, research, investigation, but also competition proposals for Tallinn Biennale.
Yeah, so the first semester was we decided to do a competition. There was Tallinn Biennale of Architecture, which everybody probably heard of, and there were several things going on. One of them was a competition open also for students, new habitats, new ornaments. The topic of Biennale was new beauties, so, and the competition was about creating new aesthetics of a habitat, of a living within suburbs of Tallinn. Our approach was also related to the topic of ornaments, because that's something which Central Europe really despises, doesn't like. Ornament is a crime, obviously, so we thought maybe not. And yeah, several projects.
One project was awarded by the honorable mention by Reisner in Tallinn, and that one is another one by Christine Graudal, which was sent to the competition as well.
We, unlike we do normally, because it's a competition, we allowed for the individual entries. Still, there were some group works, but most of the projects were individual, and that affected obviously the way we teach. If I remember correctly, during that project, during that semester, we asked students to look into several iconic housing typologies, starting from Maison Domino, Le Corbusier, the domino principle, then ending with Utzon's housing in Helsingor, and Habitat 69 by Moshe Safdie. I think this particular one was very much influenced by Moshe Safdie, this kind of metabolist idea of units. However, Christine sort of updated it with much more kind of free language, which is inspired initially, I think, a little bit by kind of rural or this kind of typical architecture with traditional rooftops. However, by turning the houses in various orientations, she creates a landscape which consists of rooftops transformed into the staircases and terraces, etc., etc. In another project, which again is a little bit inspired maybe by habitat principle of slabs, domino principle of slabs, but also maybe of Frank Lloyd Wright prairie houses. A student of ours, actually Erasmus student, scripted an algorithm of creating imperfect symmetry. She would take a very simple unit and she would symmetrically mirror it, and then she would break the symmetry but by one tiny mistake. Iterative application of this process created this, I think, very beautiful ornamental structures. You can see them from top, and then manipulating with them in 3D created this idea of villas or houses with a really intricate geometry.
What's important on those projects is that they are not our most of them are not done by our 6-year study students, Czech students, but Malin, she was Erasmus student from Sweden, staying with us for 2 semesters. Previous was a Christine Kravgal, which is visual art student. So it means that we are very happy that we can work with students, not for 6 years, but also students staying, visiting us for a shorter period, and we can make interesting results because their previous experience and our experience.
In another case, this time a group of students, our students, 6-year students in this case, have approached the topic of ornament through, again, algorithmic generative growth process, you know, the process which you can see in corals or in you know, brain cells or everywhere in nature. They highly formalized it, creating this very kind of symmetrical, crystal-like, almost snowflake-like shapes. And they tried to implement different stages of this growth in kind of mushroom-like shape to create, again, something which is surprisingly close to the Le Corbusier idea of domino. So we kind of enjoyed. We're on one side we're kind of trying to be critical of modernism, but then again we really are happy when we can you know, sort of create this discussion with modernism, but using contemporary language and contemporary technologies. So this is sort of rethinking of domino and of this pillar and slab system through the language of differential growth. And here is some image. In other cases, the projects were maybe much less moderated, but definitely not less interesting. Stepan Krahulec, our student who is cooperating quite a lot with Francois Roche and very much inspired by Roche's way of thinking about new ecologies and sort of new speculated future and total lack of control, proposed this habitat of the future, kind of anti-utopian, dystopian habitat of the future, basing on sort of breaking all possible rules which you can have within algorithm to create something quite opposite of the rules, although using mathematical methods.
That just demonstrates how different projects might be according to our previous discussion about computational design, if it is our goal. But you know, the spectrum is very wild, and each project can be totally different according to the strategy and scenarios we are looking for.
This particular project was very different, and I personally was actually very critical of it. To be honest, I'm still critical of it, but I included it in the presentation because somehow I guess jury liked it, because this was the only project among those which students sent to the competition which got an award. So although I wasn't and still not very happy with it, maybe yeah, there are different ways of thinking about it, because one of the projects yeah, got awarded, and it was this particular one. Among other approaches was sort of inspiration of brutalist architecture and brutalist principles. However, let's jump to the next one. That particular
Shota,
yeah?
before you continue, I know that you got a flow and it looks good, but there is a question regarding the pavilion that you were showing, whether you have a video showing an assembly process.
Some maybe, yeah. The Milano pavilion, the black and white things. This one, there is a video on YouTube. I'll after this presentation, I'll try to find it and can post the link.
We can post the link in the comments of the Facebook.
Exactly. Yeah.
So
Yeah.
also the recording on YouTube.
For this pavilion, I think Sheboliki and Itebe also did some video, but it's not really assembly process video. It's more like a bit of promotional video, but I can also post the link. Why not?
Okay, yes, let's do that. It was about this one. The question was about this one.
About the red one?
Yeah, the red one.
Yeah.
I didn't know, but now we've got a comment. Okay,
Right.
sorry for interruption.
Oh, no, it's okay. So jumping on, this semester was very different because it was a competition and it was individual projects mostly, which is exactly the opposite of what we do. But the next one was sort of more related to what we do generally. We kind of continued with topics of ornaments up to a point, but mainly we jumped to the topic of post-Anthropocene, where kind of trying to reflect this idea of post-Anthropocene, mostly promoted by Luke Young, that you know, we come to a point where the machines and the artificial intelligence, although they don't seem that smart yet, still as simple as they might be, they already took a lot of decision power in life and you know, in economy, in politics, etc. And the kind of hierarchy of what's important totally changes, which could be illustrated by things like, you know, server rooms of companies like Facebook and Apple are much more influential for today's life in all kinds of areas, from politics to aesthetics to economy. Yet then you know, the traditional institutions. Yet mostly these server rooms are totally uninterested architecture of IKEA boxes hidden somewhere in the countryside or in the desert or in the far north. And historically, architecture was always kind of reinforcing the hierarchy. You know, the banks tried to look sharp, and the palaces and the churches, etc., etc. And now there is this switch, and how should we acknowledge it? Is it okay or is it not okay? Does it mean that there is loss of public participation in these new centers of power? So we asked students to look into these ideas of post-Anthropocene and design their post-Anthropocene architecture. Most popular topic was actually designing a server room for undisclosed client. One particular project was concerned with putting a server room in the middle of a metropolis, in this case in New York. Considering that server room is architecture without people, and when you don't need people, that also means you don't need windows because you don't need sunlight, and you don't need horizontal slabs, and because you don't need people going through, and you don't need stairs. So, you know, if you think of architecture but without windows, without slabs, without stairs, what's left? Not much. And how that can be transformed to the contemporary language. The students in this case researched the structures built by animals, by ants and termites, which through some sort of emergent processes of cooperation and communication create immensely complex structures, structurally, but also in sense of thermal insulation, or in sense of, you know, creating climate, which is an important topic for the server rooms. So they created this termite-like nest structure, which would work as a huge chimney and would take the hot air up and would take the cold air from the outside, and would be populated with little server racks, which would be serviced by mostly by some kind of automated system on the rails. Again, when we can't build something, we make at least a model. The same topic, the server room, but approached very differently. in this case, approached as a structure put in the public space in a park, and a structure which doesn't have really a start or an end. Servers as a network where you can add more or take out some, etc., and which can be transformable constantly, and you know, create this this kind of post-Anthropocene park public space. This particular one was placed in Torino, on the place where there is this historical Torino factory, and obviously the author was a bit inspired by the kind of monocoque structures of cars, of Fiat cars, to create his modules. To continue with servers, this particular project considered the fact that after all, it is IKEA boxes for a reason. Server racks are basically squared, and putting them in boxes is actually economically very efficient. So how can we work with it? The author created an algorithm of deconstructing and breaking these boxes by kind of moving it around a little bit, copying it around, and creating a rectangular structure, which is, you know, rectangular, it's efficient, it's there are just straight angles, yet it somehow is incorporating the public, and yet it also has kind of rich visual language. These huge blocks of server rooms, a little bit like ancient pyramids or Maya structures, they create little sort of wormholes inside of them, which could be populated by the public. So while the public cannot really get in, it can kind of get in, because the surface of the rooms is you know, having this kind of complex topology. And jumping to the material side of the projects, we very often have as a part of the task, or as a different task, a project which really starts with deep material research and which doesn't really have a program. In this particular case, it was a sort of a continuation of Milano, of the foam project. One of the things with that foam expansion thing was that we thought that the polygons, the cardboard polygons in which were kind of blocking foam expansion, were so solid that the non-determinant part, non-predictable part, was not very much seen. So we thought, okay, let's make it less solid. Let's incorporate them in something kind of more transparent, more unclear. And another thing was, let's automatize this process. That was the time we actually managed to borrow a robotic arm, which eventually stayed with us, and tried to cooperate several aspects. One, research of foam, how it expands, how you can affect expansion, control its expansion, but also leave it go wild. Research of topology, shape, how to kind of create this envelope in which foam expands, but also research of technology, of how to, you know, do all this without making your hands dirty. Here, just to give you an idea how the process was working, we're using the form, which was pneumatic balloon, so we can use it multiple times, you know, reuse the form. Being environmentally conscious is important. We used glass fiber or carbon fiber to kind of create this bit, and then we would expand the foam inside, and the foam would serve as a fill, but also as a binding element for the structure. This time we ended up with a rather small prototype. Another material project continued the research from a Tallinn proposal of growth, and applied it for a very thin layered formwork for concrete. So again, we took something which was already this idea of mushroom-shaped buildings, and then we thought, okay, how we would build it. Now everybody is working with concrete 3D print, and it is nice, but we thought we want something different. We didn't like the roughness. We thought, okay, let's just go with traditional approach of pouring concrete into existing formwork and 3D print the formwork. Because 3D printing is rather slow, we thought we should make the 3D printing formwork super thin, so you can print big stuff relatively fast. But because you need certain solidness to have concrete not to destroy it, we would pour concrete inside and sand outside at the same time. That obviously meant that that brought limits to the topologies which we can do. So then again, the algorithmic part, the kind of scripting part became important, because we needed to create a formwork which was basically one single closed curve at any point of the time, and that was something which algorithms really fit into very well, because it's very geometrical, very mathematical requirement which you can clearly, precisely define. Coming back to the I'm actually not sure why I put this slide after the material projects, but coming back to the post-Anthropocene, not everybody did servers. This was a logistics center, a project which was quite interesting, because the scripting was implemented not in a traditional way of designing fancy geometry, which there is some quite fancy geometry, but also in a way of proposing a program in a way that the amount of different parts of the facade required for logistics, for the drones to land, etc., etc. The amount of storage space in the middle, the amount of elevators, etc., was calculated based on the existing needs of contemporary European city. So this is basically this drone terminal for logistics of small shopping. And finally, the last thing to show are diploma projects. Diplomas are different because the students do them always alone. That's school requirement, not ours. And the students are also free to choose what they're gonna do. Maybe I'll ask Imro to talk about the diplomas.
Yeah, diplomas are for 1 year. They spend a semester for thesis, written theoretical thesis. Mostly they spend most of the time for concept. And then second semester, the design is developed by themselves. This is one project, skyscraper or vertical digital geometry investigation for Miami skyline, where the architecture tools, programming and scripting was used. Another project which is out of computer control is mostly oriented to the greenery and nowadays ecological aspects. So that was one of our design proposal, diploma proposal. Another one, confrontation with a Hollywood countryside, overlapping the existing highways, overlapping by artificial landscape, which holds hidden spaces, cave spaces, but also covering the highway by the new landscape covered by palms and greenery. So that's the result of just one kind of speculation. Another one, speculation for Far East Asia country, for Singapore, is that 3D structure system, city system or programming system how to create the layering city landscape. Another totally different approach is kind of apocalyptic landscape for a future where people can survive on the earth and they have to be hidden in the neon arc and maybe probably escape the earth. But this is the speculation how to use the abundant Olympic Stadium in Tallinn and convert it to the Noim Arch for survivors in the earth in the apocalyptic future. Other project, which was pretty smart, investigation of the skin and transforming skin research to the form of architecture, and the project was about the research center for Princeton University in Roosevelt Island in New York. That was done by Veronika Miškovičová.
All these projects, quite conveniently, we had an opportunity to present in Ars Electronica in Linz last year, both Tallinn, the post-Anthropocene projects and the diploma projects. So yeah, that's, I guess, what we will end the presentation with. Ján?
Yeah, I'm here. So just like that, right? That's the last
slide.
Sure. Yeah. Okay. We have another comment on Zoom regarding a project, but it was probably some slides behind. Maybe Gizem could tell us which one was it. Says this project sounds interesting. Server room. Oh, it's that one. I've never had an idea it would be a design for a server room. Yeah, that's the post-Anthropocene theme that.
The termite one or the boxes one?
I don't know really.
This or this or this.
I think the general idea of designing something, yeah, this one. Designing something for not really people that.
Yeah, it's really interesting, and it's something which kind of I find a little bit worrying, even because when it is designed for people and when it is in the middle of the city, in any way, no matter what, it's some sort of in public mind and public control. You know, you never would do something really bad in the place where everybody sees it from the outside and sometimes from the inside, but you know, when the most of our money and most of our power is happening somewhere totally outside of public sight, that is concerning, and that is something which I think architecture doesn't have an answer yet, because well, we might very well propose building all these servers in the middle of Manhattan or Paris or Berlin, but the fact is that in reality, they're built in the middle of Oregon because it's cheaper and because they can use dirty sources of energy and nobody would care. And yeah, that is an interesting topic.
Could you tell us a little more detail about your experiment with carbon fiber?
No, no, I will try. Yeah, this particular one. Well, the idea came from the fact that, you know, the Milano project, let me go there really fast, was supposed to be kind of uncontrollable or emergent on two different levels. On one level, which I think we succeeded, is kind of overall shape of the thing consisting of this little polygons was defined by the fact what how the foam would pour down and how it would create kind of structural elements, because the paper itself is very weak. It's solidified foam which holds this together. However, another important point from us was that the surface itself would be also super unorganized, which you can see kind of here with foam expanding and getting out. However, this is like maybe 10% or even less, 5% of the surface. Most of it is rather predictable blocks. And with the carbon fiber approach, we thought how to change that, how to use much less of this material. In this case, it was paper. You couldn't use much less paper because it wouldn't be able to hold itself before the foam solidifies. So we needed to pick something much stronger than paper. Also, paper was always kind of placeholder because you can't do stuff outside from paper. So we thought, okay, what's the strongest thing we know? It's carbon fiber. Carbon fiber, if you use it with epoxy resin, it would solidify. It's incredibly strong. It's very thin, so like you see here, the foam almost totally hides it. You need some sort of foam work for that. So we used balloons because they are reusable. You don't need to throw them away. You just take the air out and then take it off and then do a new one. My biggest pity is that we didn't really manage to create this fancy pattern with the robot, with carbon fiber, because it's quite challenging motion-wise. Like there are restraints. You don't want to hit stuff. So eventually we ended up with kind of several layers of this one. So you take this spirally thing, and then you rotate it and you do it again and rotate it, do it again. So you have 3, and it looks a little bit more messy, but if I would show you a close-up, it's not that messy. So it's a little bit of a pity. And another thing is with a kind of hindsight, it was a little bit maybe too much to solve, because you have to deal with the kind of chemical research on foam expansion, how much foam, how much one element, another element, etc. Then you deal with the research on topological things, what kind of shape with carbon fiber, and then technological research of how to automatize it. And this was, I think it was quite nice compromise, but nothing is too, eventually nothing is too advanced. Like the carbon bit could have been better, and the foam bit could have been better, and the topology could have been better. But for that, we probably would have needed to just focus on one particular bit. It was actually going live during the exhibition, which was really important to us to make it in a way that the robot with some sort of observation from a student who was sitting there could actually do the stuff while visitors are coming and going.
So it seems like Gizem would like to speak. So let's listen and let's start the debate.
Hello, my voice is coming.
Yes.
Can you hear me? Yeah, thank you so much. Firstly, I would like to thank you for your presentation. It was so great, and to see how things going on in universities in global scale. I mean, I'm from Turkey, and we also try to do things like computational design. But when things comes to the solving plans and sections, we all stuck. So are you caring about solving plans or section in your projects? I mean, we weren't know that gross software and scriptings, so we were not able to solve. But I'm sure you will also you also cared solving plans and sections.
Thank you. The question makes a lot of sense, and well, we try. That's probably the most precise answer I can say. It doesn't always work out, And but it's always when we start a project, we say, okay, this time we're going to do it in a way that you can actually we always want to make it in a way that you can build it. We are not that much concerned about following maybe particular building code, because building code is not just about what are the needs of of people who use the building. It also has lots and lots of stuff related just to some historical conventions or some kind of heritage which doesn't really work anymore, or some kind of stuff related to the system of of control, how to make things simple to control, etc., etc. So we don't care about that much, but it's always our ambition to work, to have plans, to have sections, to have. We don't care about visualizations actually that much, because mostly we would want from students to submit plans, sections, and physical model. Students themselves mostly want to also do visualizations, so that's kind of more coming from them. But yeah, we do care. It is tricky. We know that it is tricky. Sometimes we succeed, sometimes we are not so successful.
Yeah, because it's really important to know, like after graduation, like sometimes you just jump into the professional life, and while you are studying, you were like think more conceptualize. So it's good to know something you can build, like something you can build while you are thinking conceptualize. Like, it's good. Thank you so much.
Thank you.
Maybe I would like to add a little bit that training in the academy, in the architecture school, is sometimes very limited. And if you are, if academics focusing to teach you how to design a building, of course you have to visualize in a way of the plans, sections, etc., etc. But some of those projects showing you that you are researching just part of the problem, and the result is not to design the whole building, the whole family house or something. Sometimes you spend a lot of time just designing a detail of the process, and if you are pushed in your school to after semester to design a complex building, of course that you are stuck, and that might be a problem, because it should be recognized by your tutors that what you are doing. If you're doing the research, if you're researching the part of the building industry or the just of computing process, or if you are designing the family house and you're using design tools. So that's the problem, that sometimes you are stuck because the task is not clear, very well described.